Good afternoon. Welcome to Compass. Our speaker today is John van Leer. And I looked up his CV a little bit yesterday. So he grew up in Maryland. He got a bachelor's degree in mechanical engineering at Case Institute of Technology in Ohio in 1962. And then he spent 3.5 years at the MIT Instrumentation Lab working on re-entry guidance systems for intercontinental ballistic missiles. So that was a quite different direction than what he did in his later life. Then he went to Woods Hole and started to work with Henry Stommel, pretty famous name, and got a Doctor of Science in Physical Oceanography in 1971. Also in 1971, he came to RSMAS as an assistant professor on the tenure track in the division of physical oceanography. Then later he got tenure, of course, he became an associate professor. His page there mentions that he is an expert in ocean instrumentation, impacts of global warming on coastal Florida, Arctic drivers of these climate changes. He developed an instrument called the Cycle Sonde. That was a big achievement, I think. The first moored automatic ocean profiler system with real-time telemetry. 4 successive generations of that thing, and many experiments were done with it. He participated in dozens of research cruises. Altogether, the webpage says you were at sea for about 4.5 years. That's a lot. Research cruises to the Atlantic, Pacific, Arctic Ocean, Gulf of Mexico, Bahamas, and the Great Lakes. There are 32 peer-reviewed articles and book chapters and numerous technological articles. He's still teaching some courses, so in general the teaching interests are in physical oceanography, marine sciences, climate change, and sustainable living. But we mostly know him now as a climate activist who is very active, involved in some international organizations that act to mitigate global warming, and that's also the topic of his talk today, Pathways to Negative Emissions.
Well, thank you very much. Yeah, I got the 3rd degree out of the joint program between MIT and Woods Hole, so I went back for the 50th anniversary of that this last fall, and met with some people I hadn't seen in quite a while. Interesting thing also to see how far advanced the observation of the ocean has become in recent years. So I am a physical oceanographer, a mechanical engineer, and I am a climate activist. I'm trying to do whatever I can while I still can to reduce emissions. And in fact, the emissions objective is to go negative. That is, we want to be able to sequester more carbon than we're putting into the atmosphere. So that's the objective. And going back to earlier times, Ben Franklin basically said an ounce of prevention is worth a pound of cure. He had many sayings which still persist in the American conscience. And basically it's very apropos to this one because serious global emissions reductions will be far more effective and hundreds of times cheaper than fortifying the coastlines of the world. In fact, it's probably thousands of times cheaper, and so it's much better to act aggressively in advance to reduce emissions. That's the cheap way out, as well as the most efficient way out. So this is a copy of the Keeling curve, which the good folks at Scripps have annotated with different events, starting from the beginning, 1958. That was when I was a high school student, just graduating, and going till practically the present day. And it has all these different events on it. Exxon Mobil predicted that burning oil would produce global warming, and they chose to put that in the back burner somewhere in the filing cabinet rather than publish it. And first funding of climate denial institutes. There are just dozens of these things around which put out misinformation for the purpose of confusing people and delaying the transition that we have to make. So if you go through this, Gore lost to Bush here in Florida. And so if you don't think it's important to vote, remember that, because a handful of people more who could have voted for Gore would have made quite a difference. And so we go through this whole thing, the inconvenient truth, COP21 in Paris, the climate denier becomes president, Greta Thunberg, viral speech at COP24, and a climate denier became president of Brazil. So there are some major things that have happened. And it really brings to the idea that non-binding resolutions and setting goals is great, except that it doesn't really accomplish anything binding. You need to have legislation. It needs to be bipartisan so it will endure. Otherwise, it will flip every time you change administrations, which is what we've seen lately. So it's very important to do something that makes an enduring difference. And this is late-breaking news from the IPCC Special Report on Oceans and Cryospheres, Chapter 4. And this is a particularly long timeline for them, because it starts in 2000, goes to 2300. So it really looks at the deeper future. What are we going to have to deal with? And there are two sets of points on here. The one that's colored blue and is lower, those are projections if we make the maximum possible effort to reduce emissions and reverse global warming. That's what it could look like. That is an aspiration that we can have. Will it happen? We don't know. It depends on what the people do. The top one is essentially business as usual. This is what we are now doing today. And you'll notice that the error bars on that are particularly large, because the harder you drive the climate system, the more likely you are to find ugly surprises, like mass melting of permafrost or runaway glacial discharge from Greenland and Antarctica. And so much bigger uncertainty. These are both probably lowball estimates, because the IPCC is very cautious. After the scientists get done, before they release the report to the general public and to the so-called policymakers, then it has to pass government approval. And so that always lowballs things. So the sea level rise that you see here will probably be significantly larger than what we see these projections doing. There are two important points about this. One is that the lower curve actually has an inflection point and begins to reach an equilibrium state. And the upper set of curves keep rising indefinitely into the future. That's a really big difference, because if the world could stabilize at a higher sea level, it would be a whole lot easier for humanity to live on our planet. So this is where we usually stop thinking, at 2100. Already by then, starting in about 2050, the differences between these two emission scenarios become evident. Until then, it turns out that there's so much energy trapped in the ocean that there's thermal inertia that's working on the system. So it's not something you're going to just switch this around in a day or two. 2050 is when you begin to see separation between these two things. But it bears watching, so we should have aspirations like that. This lower curve we'll see at the end of the presentation in the 2015 Climate Compact Sea Level Rise forecast. So, for me personally, the most worrisome thing about the climate is the permafrost, and particularly the permafrost that is found underwater on an enormous shelf in Siberia, and it contains permafrost hydrate system and their associated methane that's essentially trapped in the hydrates, which can be released in the East Siberian Arctic shelf. There's a recent 2019 article by Shakova et al., which is the most up-to-date that I've seen, and it particularly treats these underwater permafrost deposits, which are so worrisome. And so this is the motivation why we should do things and do them quickly. This is a figure one from that paper, and the interesting area here is this Eastern Siberia Arctic Shelf region up here, and the areas over there, same map, but the red areas are less than 50 meters deep. That means that warming of the surface layer and storms can thermally abrade the bottom and stimulate the release of methane. So this piece of continental shelf is the largest continental shelf in the world, and is thought to have 1,400 gigatons of methane contained in permafrost, which is 400 to 800 meters thick, in the form of hydrates. So hydrates are stable at cold temperatures or high pressures. You find them in the Gulf of Mexico at the bottom. In fact, the flash evaporation of those hydrates is a likely source of the instability that caused the deep sea horizon accident, because the sudden gasification of the methane hydrates drove the drill string up through the crown block with lots of methane, a lot of oxygen, and the people who produce oil and gas don't know how to deal with hydrates yet.
John, for those of us who haven't taken chemistry in a long time, can you remind us what hydrates are and what's the chemical?
Pardon?
What are hydrates? What's the chemical?
Hydrate is a cage of ice around individual methane molecules, so it has the effect of stabilizing them.
So it's methane with water?
With water, frozen water around it. It looks like old-fashioned moth crystals. If you hold it in your hand, it'll begin to outgas methane, so you can light it and watch it burn in your hand. But in the Arctic, it was so cold for so long that it was stable. And so the question you might think about is, how does this compare with what's in the atmosphere today? 3 gigatons of methane were added to the atmosphere since the Industrial Revolution in 1750 and forward, which caused, according to this article, about half the current global warming. And there's 5 gigatons in the atmosphere as of 2013. So what's particularly worrisome, according to these authors, is that there are 50 gigatons of methane that could be released at any time from the East Siberian Arctic shelf. And such a release would constitute a tipping point. You hear about tipping points quite a lot. This would be a particularly ugly one because it would be self-reinforcing. You emit the methane, it heats the atmosphere, melts more methane, heats the atmosphere. It's what they call positive reinforcement, but it doesn't mean it's positive in the usual sense of positive. So 1,700 gigatons of methane could be held in the sediments, including both hydrates and free gas. There's also free gas found in these deposits. And this is a graph from the Vostok ice core showing the correlation between temperature and methane, which is something that I think emphasizes the hazard of mass methane release. So before the last 3 decades, this whole show was frozen, and there was thick multi-year pack ice on top of most of this region. When I was in the Arctic in the 80s, I drilled and excavated through 5 meters of pack ice, 15-year-old pack ice. There's hardly any pack ice left that's more than a couple of years old today. And so there's a lot of open water. Open water absorbs heat. That heat can melt the bottom, and so you have this kind of a reinforcing feedback. So the methane emissions from the East Siberian Arctic shelf are no less than the Arctic terrestrial ecosystem, but they continue year-round because there's warm water on the bottom. And so the methane release, we don't know how fast it will come. It could increase by 3 to 5 orders of magnitude, according to the authors of this study. So that is the motivation for making the transition quickly. Got to do it quickly, yeah.
Anything comparable in Canada?
We have much less continental shelf width. All due respect to the Canadians, but the Russian continental shelf is enormous. And it's so wide. I mean, it's 1,000 kilometers wide. I mean, imagine a continental shelf that big. It is absolutely enormous. It's also very hard to get to, and so it hadn't been investigated in depth until recently. So they undertook a multi-year, 13 annual cruises, 2,700 stations. That's places where they stop to make measurements. That's an enormous observational program. And they also did winter drilling from the fast ice, which is ice that remains frozen to the coastline. So it's physically stable. It stays in the same place long enough that you can drill a hole through the ice into the bottom and not have the whole thing shift and break off your drill string. And so that's how they know what's happening under the ice in the wintertime. And they've determined that bubble streams in depths less than 50 meters can easily reach the surface, and it dramatically increases the methane reaching the atmosphere. So there's a methane hotspot sitting over this place. So there's a lot of permafrost on land. Siberia is full of that. And a recent development, they started to notice these craters that formed in the permafrost. And these are all 100 meters or bigger in diameter. They are 100 meters or more deep. Usually there's water in the bottom of them. And they're thought to be formed by a methane pressure exploding the plug of permafrost above the crater, blowing it out of the hole. And then the edges of these craters are upturned like a meteor impact crater. And so there's 7,000 of these, and as they age, they begin to lose mass along the side by thermal erosion. That's a feature called thermal karst. And you see that all over Alaska, you see it all over Siberia. And when they get older, they can get to kilometers in diameter. There's some old ones that are like 20 years old that are a kilometer and a half bigger than that maybe. So other recent developments, we've had a couple of fascinating special reports. Lately, there was one in 2018 about what you might need to do to limit global warming to 1.5 degrees above pre-industrial. And so the recommendations were a 50% emissions reduction by 2030 and a 90% emissions reduction by 2050. And so if we want to arrest the emissions and reverse emissions in a timely way before the permafrost has a chance to belch out the methane that's sitting there, we need to do this quickly, and the question is, how could we possibly get there? So there's a lot of things that are already happening. One is you can work to elect candidates that have reasonable ideas about carbon and plans for that. You can lobby to pass legislation which aggressively prices carbon, which is something that I do with Citizens Climate Lobby. You'll notice I wear a button, a Citizens Climate Lobby button, and they, I think, are among the most effective people in Congress. I've been up there now for 5 years to lobby Congress directly, and we lobby in the local district for legislation to price carbon, which is bipartisan. That is the key. There's also litigation going forward. There's litigation, a group of children, 21 children, basically are suing the federal government for the right to have a livable world as they grow up. and that has James Hansen as the protector of the people. Hal Wanless is on their committee as a special a person talking about sea level rise. And it has been slowed down. Every legal maneuver you can imagine has been used. However, it has not been stopped. It was introduced in Oregon in the circuit court there, and it's still working. There's a parallel lawsuit going on in the state of Florida against our government for the same purpose. Delaney Reynolds, who's a sophomore at University of Miami, is the person who's bringing the suit. And of course, there are all sorts of ideas of blocking construction of pipelines like the Keystone XL pipeline and the gas pipelines, which are essentially the arteries of this carbon industry, and also blocking export terminals by any means. So that's the kind of thing that Greenpeace does. There's also the idea of institutional divestment of carbon securities. 350.org does this kind of work. They have succeeded in having $11 trillion worth of assets sequestered in this way. We are essentially financing the oil and gas industry through investments. So if you happen to have oil stock in your retirement policy, you are part of the problem. You're helping to finance this. You can also personally divest, which is something that I've done. So I don't own anything that relates to carbon stock. I inherited some securities from my parents, and so I sold off all the carbon stuff, bought an electric car, bought a solar array for the house. So I've reduced my carbon impact significantly.
John?
Yeah.
Just make sure 11 trillions.
Trillion with a T, yeah. There's some interesting folks that have the Norwegian Sovereign Wealth Fund, which largely was generated through fossil fuel income, has divested. That's a significant one. The state of California a university system has divested. And so then the question is, what can you do that could really make an impact quickly? One of the most interesting articles I've seen in a long time was written in the New Yorker magazine, September 17th, 2019, by Bill McKibben, who's the founding father of 350.org. And it's called "Money is the Oxygen Which Fires the Global, the Fires of Global Warming Burn." So it's the money system that is probably their most easily disrupted vulnerability. So, what if the banking business, what if the asset management, what if the insurance industry moved away from fossil fuel? They couldn't operate if any one of those were to decide to move their assets. So why would bankers abandon fossil fuel, you might wonder? Well, there have been some real economic tipping points in the last decade. The price of solar has dropped 90%. That's photovoltaic in utility scale arrays. The price of wind has dropped 70% already. And today, 30% of the car buyers in the United States plan to buy an electric vehicle as their next car. And grid scale lithium ion batteries are now much cheaper to operate than natural gas fired peaker plants. So in Southwest Australia, they replaced the peaker plants with a giant battery, and they are saving $40 million a year by not having to operate those peaker plants. So a banker who's paying attention to what is actually going on in the energy sector might be taking note of it. Also, the bankers' children might take part in a protest with hashtag Friday for Our Future or the Extinction Rebellion. And then the banker would have to answer to his kid, which might be a little awkward and might give him pause for thought. And you say, well, how's that going to work? Well, turns out the Bezos, who operates Amazon, faced a strike by 2,000 workers of his who went off to take part in the Fridays for the Future protest on the 20th of last month. And he ended up deciding that he would make his corporation adhere to the Paris protocols. And he bought $600,000 in stock on Rivian, which is an electric truck builder, and he just put in an order for 100,000 Amazon Prime delivery vehicles that are all electric, made by that company. So things are changing. One of the most powerful books that's been written in recent time is called DRAWDOWN. And DRAWDOWN is what happens when you reduce emissions below zero year over year. You begin to draw down the carbon. You begin to put it back in the soil where it belongs. Put it back in the ground where it's not going to hurt anybody. And so that's what this book is all about, reducing emissions and sequestration. So if we adopt the 80 drawdown solutions, which are well known and are already fast ramping, we save $44 trillion compared to burning fossil fuel in business as usual. The oil companies would like you to believe, with their disinformation, that, oh my God, if we stop using fossil fuel, it would be the end of the economy, employment would collapse, it would be the end of the world. But it's actually exactly the opposite. We make more money by doing the right thing. So we should do it for the profit, even if there were no global warming. So this little pie chart shows the 80 solutions that are already fast ramping. And it turns out in 2016 there were 36 gigatons of CO2 emitted in round numbers. And there's some things in this diagram you might not expect. Refrigeration, how in the world does that get up there? Well, it turns out that when we made new refrigerants to take the place of CFCs, which were chewing a hole in our ozone layer, we succeeded in beginning to repair the ozone hole. That was the good news. The bad news was the global warming potential of those replacement refrigerants, in some cases, is thousands of times greater on a molecule per molecule basis than CO2. So if we don't manage those new refrigerants and capture them and safely dispose of them, we're really making trouble for ourselves. And there are some things you would expect to find, like wind turbines onshore, reduce food waste and plant-rich diet. Turns out our farming sector and our dietary sector play a huge role in global emissions. If you were to become a vegetarian like Gandhi, whose 150th anniversary is today, then you would save a heck of a lot of emissions because the meat industry uses a tremendous amount of fossil fuels, and the waste from the meat industry creates a lot of methane. So I was driving through the valley in California, and we saw this hill in a floodplain, and my girlfriend said, what is that? And I said, wait till we get downwind of it, and you'll know what it is. It was a feedlot, and these cows were essentially walking around on a mountain of manure, and you know that there's methane coming out of that mountain. So we know about tropical forests. These two, educating girls and women and family planning, if you put them together, it's the most important thing we can possibly do. Because a woman who is raised in a traditional emerging economy is likely to have 5 or 6 children if she lives in the traditional way. If, on the other hand, she matriculates from high school, she becomes much more of a person on her own grounds. She can start a business, she can essentially look out for herself, and she can elect to do some family planning. So everything in global warming scales with population. So if we reduce the population growth, then we reduce the emissions. And there's no better way to do that than educating women and girls and family planning. So this is the same material arranged by sector, and here is food, which is you don't hear very much about, but it's this huge sector. Electricity generation you hear about. There's the wind turbines, the solar, the rooftop solar, geothermal, and so forth. But land use, how do you take care of tropical and temperate forests? What do you do about peatlands? There's tremendous amount of carbon sequestered in peatlands, for Pete's sake. And so in our own state of Florida, there was peat that was about 18 feet thick south of Lake Okeechobee, where they grow sugar cane. That peat has basically turned into carbon dioxide. There's now about a foot or 6 inches of peat left, and they essentially burn the sugar cane when they harvest it, and it oxidizes by direct contact with the atmosphere. And so all these swamps that people talk about, draining the swamp, that's not really a very good idea. So here's women and girls again. What we do with land is important. Materials is largely refrigerants, and then the manufacture of concrete. There are alternative ways that we can make cement that'll be better than what we're doing now. And here's buildings and cities, which you hear a lot about, and transportation, which includes things like electric vehicles and things like that. But it's not as big a sector as you might think, listening to the general media.
Hey, John.
Yeah.
I see nuclear power on your list there. How do you feel about that?
Pardon?
I see nuclear power on
Yeah.
your list. How do you feel about it?
Well, I'm not largely thrilled with nuclear power. If there are existing nuclear power plants that are not a problem, I see no reason to stop operating them, because they are reducing emissions in the short term, and this is a problem we have to solve in a hurry. I'm not a big fan of building more nuclear power unless you do it in a way that has less radioactivity than what we do. There were interests in building, the Norwegians particularly were interested in building nuclear power which did not use the weapons cycle. So if we were to build nuclear power plants like that, I would probably be in favor of it if it makes sense. But the price of PV has come down so fast. I mean, every time you double the production of PV someplace on the globe, the price drops 20% more.
So what is that PV? Is what?
Pardon?
What is PV?
Oh, photovoltaics, I'm sorry. Yeah,
Oh.
those solar panels you can put on the roof of your house. So those things have been mass produced, and we can thank the Germans for the early scale up of PV. There was a wonderful German theorist who was also head of the Green Party named Hermann Scheer, and he instituted something called feed-in tariffs, which allowed you to borrow money from a bank, solar panels or wind turbines, and then to pay it back over 10 years. And of course the banks liked it because it was guaranteed by the government, and the solar manufacturers and the windmill makers liked it because there was a big market that came out of this, and the individuals liked it because they could retire and have a low electric bill. So my electric bill is usually less than $10 a month, and in real heavy hot weather it might get up over 20 slightly. So it makes a difference. It makes more money than a 401k. So I would like to give you a little hope and insight. This gentleman, Ross Tessian, is somebody who has written an article about the transition to electric vehicles from the disruption perspective. The modeling that you see in the general press assumes it will be an evolutionary change. But he said, oh no, it's going to be disruptive. And so this article is The Big Auto Oil Implosion, published by Seeking Alpha, in Seeking Alpha. And so he's using market ideas from disruptive technology as the model.
What's the theory?
Pardon?
What's the theory in the article?
What's
the theory?
The idea is it's a disruptive event rather than an evolutionary event.
Okay.
And so we see a lot of disruption. This is a diagram showing the evolution of things starting back in 1900 with a telephone. So the telephone took to grow from 10% up to 90%, it took about the year 2000 for that to happen. And that was because a lot of rural places needed wires to be strung in places that weren't convenient for very small numbers of customers. But as time has gone on, you notice that these curves are getting steeper. So it's going from 10 or 20% market penetration to 90+% very quickly. So you see things, radio took a little while, the internet took a little while, smartphones not so long. Microwaves are pretty quick, digital cameras, tablet computers, these things are going almost vertical on this timeline. So if you have a product like an electric car, which is so much better than a fossil car, it is likely to be disruptive. And that's the thesis of what he's trying to go at. And so he said the decision to purchase a new car is separate and is independent decision from the decision to purchase an electric car instead of an ICE vehicle, an internal combustion engine vehicle. ICE. It's not only the people that deport aliens, but anyway. So when somebody decides that their next car is going to be an EV sale, the sales of ICE vehicles drop immediately because they're not buying one of those. They decided not to. And so it might take them 3 or 4 years to find a vehicle that meets their budget and meets their druthers as to what the properties of the vehicle should be, but the sales loss starts immediately. And so he says that the drop in vehicle sales is essentially due to this, which the automakers would like us to believe it has to do with people's sudden preference for SUVs and trucks. That's what they would like us to frame it. So, but OPEC, which certainly would be in favor of internal combustion, has estimated that the number of vehicles, electric vehicles, is going to go from 46 million for 240 to now 266 million. That's almost 500% increase in their estimate. Why is OPEC increasing that estimate of vehicle penetration? So he anticipates by 2030 around 700 million EVs will be in the global fleet. This is 3 times the cars in a decade less time than OPEC is estimating. And that's because he thinks it's going to happen as a disruption rather than evolution. So he thinks the ICE car sales will approach 0 around 2026. There are now a dozen countries in the world who are not going to allow ICE vehicles to be made and sold in their country. Some of them are small, like Norway. Some of them are big, like China, which make a big difference. And so around 56% of the consumption of global oil is demand that comes from transportation. And you have other demands like heating, 11%, and power, about 5%. And these also are in the process of seeing disruption as well. So he thinks there's going to be an oil glut. EVs have already reduced oil demand by 250,000 barrels of oil per day, largely because of electric buses. If you live in the United States, you can't imagine that, but in China, there are electric buses everywhere. Dade County Commission tomorrow is going to consider a motion to buy a fleet buy of electric buses between 36 to 70 plus buses in one shot. They think it's a big deal. So if you'd like to support that, you can go down to the commission chambers tomorrow and sign up and make your voice heard. So this is where the disruption comes in. So the number of cumulative electric vehicles increases by 50% every year. And there's now 2 million of them that were sold in 2018. The amount of oil displaced will continue growing at the rate of about 15 barrels of oil for every EV sold. So that's going to begin to collapse the market. So Ross expects ICE sales to drop first and then EV sales to grow later. He expects that EV sales will make up more than 90% of the total sales by 2027. And Mr. Tony Seba says that China has 300 new EV companies. That's because they're going to eliminate ICE cars. And of course, Tesla just opened their factory in China, and their first production is going to roll off shortly. So Ford and GM basically declared that they were going to have lots of EV options that they're going to make in the future. They don't have them yet, except for the Bolt, but that made their customers, or loyal customers who wanted to stay with the brand, think about it, because now they think, oh, I'll wait for the EV. So inadvertently, they shot themselves in the foot. And so what we see here is the oil displaced in millions of barrels of oil per day, and you see it's a very rapid increase as you get past 2025 and then up till 2030, a huge increase. And so this is the cumulative oil that has been removed right there. So you see, cumulative EVs on the market, which has about the same shape as the other curve. So there are between 25 million in the US and 100 million worldwide that have removed themselves from the new ICE car purchase, according to a AAA survey. Ross said the consumers have believed the legacy auto hype that they are about to introduce new passenger EV options to go after Tesla, but they have decided to hang on to their older car and use that until they can get an EV with the price, features, and that they would desire. And so passenger car sales have collapsed as a result of the shift in desire towards EVs. And so this shows how the marketing works. Essentially, ICE sales are these blue rhombuses. That's his idea, that they're going to collapse as the EV sales ramp up. So basically it's ramping as a disruption, not as an evolution. And as that happens, there's a dip in total auto sales, which we see at present time. And then you see a response in the reduction in demand for oil in millions of barrels per day. And that is what's going to disrupt the oil industry. So the oil industry has problems when they have 1 million barrels a day of excess capacity. The people in OPEC begin to quarrel with each other as to who's going to take the hit. And there are a lot of countries that are one-trick ponies that only have fossil fuel to sell, like Russia. Are they going to cut back their production to make up for the shortfall? I don't think so. So it's going to be hard to apportion the scarcity. So recently added sources of oil like fracked oil, tar sands oil, Arctic oil, and offshore oil are the most costly sources of oil compared to conventional reservoir oil. So they're the most costly. That means they're going to be the first to go. So when you're a banker thinking about financing a fracking well and the price of oil is collapsing, are you going to be putting your money into that fracking well? And that is not a thing that seems to be happening. In fact, there's already softness in the fracking industry. They over-frack for oil, and so bankers are backing off because the price is going down already. So the recent sources are going to be the first to go. So the offshore oil, like what spilled in the Gulf of Mexico, will be high on the list. So this gets to what I think is the most appropriate approach. This graph has essentially different emission scenarios. Each one of these little curves is an individual model run, and this heavy curve is essentially a consensus, that is an average of all those model runs. And so this is RCP 8.5. This is what we do if we continue with business as usual and have a 3.2 to 5.4 degrees C increase in global temperatures. The kind of emission scenario I like is something that's less than the RCP 2.6. that's what's thought to be consistent with a 2 degree C increase since pre-industrial times. And you notice the average is going below zero. Negative emissions, more sequestration than emission. And so fossil fuels appear cheap today compared to clean energy, although that difference is shrinking to practically nothing. And fuel companies have had a century to lobby Congress to establish tax breaks, depletion allowances, all kinds of incentives for more fossil fuel production. They spend an average of almost $1 million on each member of Congress, either in direct contributions for their campaigns or in lobbying costs. Who do they hire as lobbyists? Mostly retired members of Congress, if they can afford them, because they know how the system works. They have personal contacts with people who are still working in Congress. So those are the gold standard. So we're basically having all these incentives, which date from a time when it was thought that having more fossil fuel was a good idea, which has been long since. But what this does not include is the damage which is done from the combustion of the fossil fuel. So these are what are called externalities. These are things which are not included in the price. At the top of the list here is sea level rise. I don't know whether you've noticed under the building, there's water coming up through the drains. That might be a little bit of a clue. Infrastructure loss, property loss, salt intrusion. With another 2 feet of sea level rise, we will lose our aquifer, which provides us with cheap drinking water. Not a good thing. Extreme weather. Imagine if the recent hurricane that camped in the Bahamas had camped on top of Miami for 2 days. You know, we'd all be homeless right now. And of course, there's business disruption, crop loss. We see the flooding in the Midwest has not allowed farmers to plant their fields this year in the breadbasket of the U.S. And of course, you have geopolitical risk, national security risk. The migration of people from Central America does not make mention of the fact there have been 5 drought years in a row in Central America. And if you're a traditional indigenous farmer, how the heck are you going to make a living and how are you going to feed your family if you can't grow crops because it didn't rain anytime recently? So economists prefer a carbon fee and dividend because it's market-based, it's revenue neutral. That is, the government doesn't keep the money. It's technologically neutral. The government does not tell you what to do with your money when you get it as a refund, and it stimulates the economy. So there's a wonderful Wall Street Journal opinion page written on January 16th, 2019 in the Wall Street Journal. So take a look at that. The surprising economics, it creates 2.8 million net new jobs compared to business as usual. It grows the GDP and the real disposable income of people. There hasn't been any real growth in people's incomes in a long time, unless you happen to be in the 1% range. Then your income is growing like crazy. Saves 13,000 lives a year. That's mostly with reducing coal-fired power plant emissions, which are a predictor of early mortality. And it cuts emissions farther and faster than the EPA regulations. So the gentleman in the middle is George Shultz. He was Secretary of State and Secretary of the Treasury under Reagan. He held cabinet positions in the Reagan and Bush years in every administration, held more cabinet positions than any living person. He's working at the Stanford Institute, essentially the most conservative think tank in the world. So he's sitting in the middle, and he basically allowed Citizens Climate Lobby to use his name on their policy. So it's called the Schultz-Becker plan. Becker is a Nobel Prize-winning economist from University of Chicago who unfortunately passed on. And the guy on the right is our national advisor, Mark Reynolds. So he's the top banana at CCL. So this is the Economist statement that was published in the Wall Street Journal, a renowned group of economists, including 27 Nobel laureate economists, 4 former chairs of the Federal Reserve, 15 former chairs of the Council of Economic Advisors, 2 former secretaries of the U.S. Department of Treasury. And so revenue neutral carbon pricing was unequivocally endorsed as the most efficient way to bring down greenhouse emissions on a scale and at a speed commensurate with the IPCC recommendations for a 1.5 degree C world. There have since been 3,500 other economists who signed on to this, including David Letson, who isn't in our audience, but he is on our faculty. So this is what we have been pushing. It's called the Energy Innovation and Carbon Dividend Act. It has been submitted as a bipartisan act in Congress, and it has a number, HR 763. So when you talk to your congressperson, you can ask them to get behind HR 763. And so for over a decade, our volunteers have asked their members of Congress to work together on climate change. So a viable climate change solution needs to be big to be lasting, and it needs to be bipartisan to be lasting. Those are 2 very key issues here. So you can ask them to support this bill. The policy will drive down America's carbon pollution while unleashing America's technology and innovation and ingenuity. And CCL supports this because it's effective. The policy will reduce emissions by at least 40% in the first 12 years and 90% by 2050. It's good for people. The policy improves health. It saves lives. Additionally, the carbon dividend puts money directly into people's pockets every month to spend as they see fit, helping low and middle income people particularly because they don't buy as much carbon. If you own 6 executive jets, 17 mansions, chances are you burn more fossil fuel than the guy who rides his bicycle to work and lives in a modest apartment. It's good for the economy. This policy will create 2.1 million new jobs thanks to the economic growth in local communities across the country. That's key because most of these solutions occur in the local economy. So the money isn't going to Saudi Arabia, it's not going to West Texas, it's staying right here in River City. And it's bipartisan, so Republicans and Democrats are both on board, co-sponsoring the bill together. The majority of Americans support Congress taking action on climate change, including more than half the Republicans. Solving climate change is too urgent to get caught up in bipartisan politics. It was not a partisan issue during the Nixon administration. When Richard Nixon looked outside of his office during the first Earth Day, 1.5 million people walked past the White House. And he turned to one of his colleagues and he said, "Oh my God, if I want to be reelected, I better do something significant." And so during his administration, the Clean Air Act was passed, the Clean Water Act was passed. He stopped the Trans-Florida Barge Canal, which would have cut our aquifer in half. He stopped the airport that was being built in the middle of the Everglades from being finished out. So he was, oddly enough, probably the most environmental president we've had since Teddy Roosevelt. And it's revenue neutral. So all the fees that are collected on the carbon emissions will be allocated to Americans to spend any way they choose. The government does not keep a dime of the money that's collected. The administration of the fees comes out of the fees that are collected. And so the idea behind this is it will skip the problem. In France, for example, the governor, the president of France, basically said that they were going to stop emissions by increasing the price of gasoline, which good idea, it reduces consumption. But there are a whole lot of people whose livings depend on driving a cab or something that consumes gasoline. So 1 million guys put on yellow vests and came out and raised hell and stopped the economy in Paris. The French are not particularly shy about making their voices heard. And so if you have refunds that begin the month before the fees are collected, then it protects the process from that kind of a problem. So the policy puts a fee on fossil fuels like coal, oil, and gas, and it puts a fee on where that material enters the economy, where it comes out of the ground, where it crosses a border into the United States. That's where the fee is assessed. And so that will drive down carbon pollution because energy companies, industries, and consumers will move towards cheaper options. The carbon dividend collected from the fee is allocated in equal shares every month to the American people to spend as they see fit. And I think that these dividends will make it not only popular with the people, but it will make it endure. Imagine trying to tell people, we're going to take away your dividend. In Alaska, they have the Alaska Permanent Fund, which redistributes money that's collected for the Trans-Alaska Pipeline. Every man, woman, and child in Alaska gets a refund from that every year. And so that's made it enduring and popular, probably beyond what it should have been. And there's a border adjustment. This is not U.S. warming, it's border global warming. And so how do you get this kind of fee to cross the borders? How do you get other countries to come on board? Well, you have a border adjustment so that if a good is manufactured outside the country which hasn't paid this carbon fee, then it has to pay the fee for the embedded carbon in the good as it crosses into our economy. So the Chinese might be much happier to keep the money in their country and collect a fee rather than pay a fee to us. So that's how you get it across the border, and there's a regulatory adjustment. If the projections of this plan don't pan out to be as we hope, then the rate of increase of the carbon fee will increase appropriately. It'll go from $10 a ton of emission to $15 a ton of emission. $1 per ton of emission is roughly equal to a penny a gallon at the gas tank when you go to the service station. So this shows the effectiveness of it. This was all done by Regional Economic Modeling Incorporated, and it was done in 2014, so everything needs to slide a little bit. But what this shows, the top curve is business as usual, increasing oil consumption. That's what we've seen. The second curve essentially shows the EPA Clean Power Plan, and it was to reduce emissions from coal-fired power plants by 30% by 2030, I think it was. And then the yellow curve is essentially the fee and dividend, showing how fast this emission is going down. So by 2030, we're down about 90%, according to this, for the U.S. And this shows the fee and dividend going up. The bright blue curve is essentially the Deutsch bill, which is essentially the bipartisan one. It is submitted by Ted Deutsch from Palm Beach and Broward County, and there's a companion Republican in the Tampa St. Pete area who submitted it together. And so this shows it the fastest rising. This is the cost as the years go forward. So as we go down the line here, the price rises. That makes oil increasingly uncompetitive with renewables. And it doesn't depend on who's in the White House. So this is Palm Beach County basically endorsed this measure. So did the town of South Miami. And so these are municipal endorsements. How about Dade, Broward, and Monroe County? The state of California has endorsed this system as a state. And the University of California system has basically endorsed it as well. So Google Citizens Climate Lobby and look for the Energy Innovation and Carbon Dividend Act. And this is the last slide, which shows the projections of sea level rise in the future, starting in 1992 and going through 2020. We are now convened again, essentially rewriting this guidance. Many of my colleagues on the panel want to drop this lowest curve, this dashed curve here, which shows the least sea level rise and requires the most aggressive carbon emissions reductions. It basically requires what CCL's plan would bring to pass. And so they think there's no chance. They've essentially handicapped it and said, well, we're going to give up on it. We're just going to let nature take its course, which I disagree with, to say the least. And so the top curve is the one that would be the most aggressive, and that would be if we allow emissions to get out of control. That shows something like 120 inches of sea level rise by 2120. So the question is, what is it going to be? Are we going to allow the carbon industry for their short-term profits to continue to produce and sell fossil fuel as they like without paying the cost of the damage, or are we going to try to put a plug in this and see whether we can stop it, make it slow down, see whether we can reverse it? So it's going to happen. We're going to run out of fossil fuel at some point. So it's got to happen, logically speaking, but it has to happen quickly, otherwise we're going to suffer the consequences of out of control global warming and sea level rise, particularly here in Miami. This is a bit of a personal issue with me because I drive through salt water on the king tides. So last night and today, my street was flooded about a foot deep with salt water. That's not convenient. It's not good for your car to drive through salt water, no matter what kind of car you have. And so I'm reminded every fall during the king tides, oh my God, this is coming. This is real. This is no joke. Sea level rise is not a joke. It's a deadly serious business. So anyway, that's where I'm going to stop. Look up CCL. Come to our meetings on the second Saturday of the month over in the Unger building on the second floor in room 230. So if you Google CCL, Greg Corman here is a card-carrying CCLer, and there are others of us amongst, and there have been several of you who have come to the meetings lately, and we need all the help we can get. These congressmen need to hear from you and me and everybody. So, thank you. Be happy to take any questions. Yes?
Okay, so I kind of want to go back to your car.
Yeah, speak up. I'm a little hard.
The car thing that you were talking about removing the amount of ICE cars.
Yeah.
So, while I don't disagree with that, I think maybe there's potentially a core fundamental problem with the way that electric is being proposed.
Mm-hmm.
And it's still promoting this transient consumption lifestyle of let's buy new, let's buy better. Do you think maybe it's possible to take what we already have, these ICE cars that are already on the road, and replace their engines with electric so that we're not like continually pushing what's new, what's best, but kind of upgrading what we already have to help reduce that consumption as well?
Yeah, that's a good idea. In fact, you could convert your fossil car into an electric car. There are kits to do that.
Great. So then
So
why
if you don't want to throw away your whole car,
So then why are 300 new car plants in China that you put up there? Why is that necessary?
well, they're not. It's like the car industry here. They aren't all nameplate makers. There are people that supply airbags, supply motors, supply brakes, supply, all kinds of things. But it indicates, because China has declared an end to internal combustion engines, it means that they are deadly serious about this. Oh,
Which is important.
yeah, they're a big market, and they make a huge difference. In Germany, Mercedes-Benz has stopped doing development on ICE engines. They have shut down their research department in that area. We got to make the beauty of electric is that you can get electricity from sources that don't involve fossil fuel.
What about the consumption then?
Well, yeah, that's a significant thing, and being able to convert cars is a way to deal with that. So you don't have to replace the whole car if you can't afford it. So for about $3,500, I can help you convert your fossil car into an electric car.
So do you see that being pushed anywhere?
Pardon?
Do you see that being like heavily pushed anywhere? Because
Well, I don't know. People, not everybody is willing to tear a car apart as I am. I used to build drag racing cars when I was in high school. I had a business doing it. So I dissected cars all the time, so that was not a big deal. So it's doable. Yeah, I agree that it's the idea that you're gonna, I mean, the ICE cars are not gonna disappear immediately. They're gonna be on the road and they're gonna be using fossil fuel for a while.
well, even when their engine gives, like we still have all this waste from those cars. Why does
Yeah.
everyone have to buy something new all the time?
Well, it doesn't, if you recycle the material, it doesn't have to be wasted, so,
Yeah, exactly.
Yeah.
To follow that, on your pie chart,
Yeah.
one of the biggest contributors was food waste.
yeah.
Reduced food waste. So I just was wondering what was meant by that. Is that solely meat or just
No, it's
specific
all kinds of
foods?
food. So if you buy more than you need, and let's say the broccoli starts to grow green mold on it, you're probably not going to eat that. So it's going to be disposed of in some way. It might be put into your compost heap if you're a very conscientious person and recycled in that way, or it might be put into the trash and go down to the dump and be part of the methane emissions from Mount Trashmore in South Dade. So yeah, and that did not count the methane emissions from the buried trash. So it's extremely conservative.
So it's all just the carbon that was burned to make that roughly. It doesn't include the.
Pardon?
It's just the carbon that was made that was used to like move and transport and grow.
Yeah,
the broccoli.
that's a part of it too. And in the Second World War, I'm so old, I lived in the Second World War. We had victory gardens. Everybody had them. Over half the vegetables in the United States came out of victory gardens in 1945. And I was part of the production team in 1945. Yeah. And we bought local. There was a farmer who still had a horse-drawn wagon, and he'd bring vegetables around the neighborhood, and his horse had a straw hat on it with holes for its ears to go through, and he had a little basket of misshapen apples. And so the kids would come out to feed the misshapen apples to the horse, and then mom would come out to keep track of the kids and buy some vegetables. So yeah, I mean, this whole thing, we saved cooking fat because it could be made into explosives during the Second World War. The amount of waste was so much less in the old days. We had return bottles, glass bottles that you would reuse over and over again. That's not exactly high tech. And they still have return bottles in places like Oregon, Massachusetts, and Maine, so kids can pick up trash and make money at the same time. A very cost-effective thing. The India in Greenland use returnable bottles.
How do you think this carbon cost that we're talking, this carbon tax that we're talking about, will affect developing nations that are more into the manufacturing side, just like Bangladesh,
Right.
produces most of our clothes that we wear.
Mhm.
And if they start imposing carbon tax on their citizens, which are mostly under the poverty line,
Yeah, but they get it back as a refund.
but would that be like,
If it's a carbon fee and dividend, the money that's collected where the carbon comes out of the ground is refunded to every citizen in the country in equal shares. So in most impoverished people in Bangladesh will actually get more money back in the refunds than they spend in carbon.
so like imposing a carbon tax would mean that,
This is not a carbon tax because the government doesn't keep it. It's a fee.
or it's a fee.
Yeah.
So that would mean that most of these factories that do not run on like sustainable energy, but run on like fossil fuels,
Yeah.
that will have to pay like an extra fee
Yeah.
for their production.
Right. And that'll encourage them to change to renewables.
So wouldn't that like require more investment in the factory side?
Yeah, I mean, it is we have to disrupt the present situation because we're not making the change fast enough. The carbon emissions globally are still rising every single year. That is absolutely unacceptable. And the people in Bangladesh who live close to sea level are going to be one of the most impacted groups of people And as I understand it, the Indian government is building a wall on the border with Bangladesh to keep the desperate people from Bangladesh from coming into India, just like our beloved president is building a wall on the southern border to keep the poor, impoverished people who can't grow crops in Central America because of the droughts from coming into our country.
I guess I just got confused because we're all like trying to reduce that emission as fast as possible.
Yeah.
But that would require like a drastic change in the production
Absolutely.
mechanisms, which I feel like developing countries don't have access to that kind of like sustainable energies on like large scales.
Yeah.
We should create like this.
Well, it's not going to be an easy thing to do. I mean, I was in the United States during the Second World War. Inside of 6 months, the factories that have been making automobiles and trucks for the civilian market were all converted to making tanks, bombers, ammunition, things for the war. And so if we decide to do this in a serious way, we convert all the factories to building the right stuff and stop building the wrong stuff. It's not, we've done this before. This isn't rocket science. I've been a rocket scientist, and this is a whole lot easier. Trust me.
John?
Huh. Yes.
I just wanted to clarify about the carbon fee.
Right.
So, going on, let's say like oil and gas. Let's
Right.
do gas to fuel our car.
Yeah.
So is the carbon fee imposed, say it's like, let's use Exxon for example.
Yeah, it
And-
comes right at the place where the stuff comes
Yeah.
into the economy.
Say it's coming from Houston, that's where we're getting the oil from. So
Right.
that Exxon plant in Houston is the one that's getting the carbon fee. They're gonna have to pay for the amount of carbon that
Yeah.
they are selling and distributing to, say, our gas station. That's
It'll
what
come
they're-
out, when it comes out of the ground, that's where it's paid. So no
That's
matter
what's
who
paid.
gets the oil, you don't have to keep
Okay,
track
so
of it.
that's what I was gonna say. So as us consumers, when I go to fill up my ICE car,
Yeah,
will I have to pay a
yeah,
tax
you'll
at
pay
the
a higher
pump?
price at the pump.
Oh, because
And-
they'll
and
raise it.
for every dollar a ton, it's roughly gonna increase your price a penny a gallon.
So I won't be paying for it specifically to the carbon fee, but I'll be paying for it because they're
Yes,
raising the price.
it's upstream in the economy, so everything downstream includes the fee if it's used for combustion. If it's used as a feedstock to make petrochemicals, that's not the case.
Gotcha.
But then you get it back as a dividend,
Yeah,
and
then-
it encourages
yeah.
you to buy an electric car or use less gas if you don't have to, and that sort of thing.
So you,
All that money is collected at the source, like John was saying, and by the government, but then all that money is collected and equally divided back through how you get a tax refund using the IRS back to every single citizen as an equal amount.
so I get Social Security checks from the Social Security Administration, and they know how to distribute it. We don't have to rebuild the wheel.
I can tell you in a minute.
The government knows how to do this.
Yeah.
They know how to give me my tax refund,
Yeah.
and it finds its way into my account. Yes,
Another question. You showed that electric vehicles, increase in electric vehicles curve is approximately, follows the same shape as oil displacement.
Yeah.
But electric vehicles is not the only mode of transportation.
oh, no.
So how does it compare percentage-wise, use of oil by, say, ICE vehicles versus oil used by as plain fuel?
Yeah, so of course, the people
percentage-wise?
with planes are gonna be paying the same fuel fee, and it's gonna increase the price of fuel. So tickets will be more expensive than they were because of the increased price. Now, there already are electric-powered airplanes that are working on commuter routes for example, from Seattle to Vancouver, you can take an electric plane today. And so as the electric planes replace the ICE planes,
But percentage-wise, how much out of the entire oil used for transportation is used by, say, airplanes and the?
it's a significant fraction. It's not near as much as all the land vehicles put together, but but it's significant. I don't remember what the exact is. I would guess
Comparable.
maybe 15% of the ICE vehicle use.
Okay.
That
So
would be
it's
a
less.
guess.
It's less than.
Yeah, less than the ICE vehicles. Of course, they're internal combustion in a way. I mean, it's inside of a jet engine, but so yeah, I'll be happy to talk to people as long as you want to hang around. But the people who have already endured enough of this and have their questions answered should feel free to leave.
Thank you.
Give you a prison, though.